Hello all, in this lesson we're going to be talking about something called function notation. So this is not really changing any of the things we've learned about functions, it's just presenting it in a new way. So we've been writing equations so far, typically with y and x or other variables, but typically something that looks like y equals negative 3x plus 1, those being our two variables, x being the independent variable, y being the dependent variable. Well, we're going to do the same thing. We're still going to write an equation for a function, but instead of writing y, the dependent variable, we are now going to replace it with this notation here. Now, this is not f times x, as parentheses have meant in the past. This is read as f of x, or the function of x. It's important to note here that f is not a variable. It's the name of the function. And we can put other letters in there. We could make a function with g or h. Those are some of the most common ones. But f is the name of the function. The variable that's placed here next to it is the independent variable. So it is basically saying that f is a function that is dependent on x. That's the input. F of x is the output. So the whole thing, f of x, we would say this is our dependent variable, and x is our independent. Okay? So let's actually get into using this, and hopefully this will continue to make more and more sense. So if we're given a function, w of x, make sure we're reading it as w of x. W of x is equal to 250x. This represents the number of words, w of x, you can read in x minutes. So how many words can you read in 8 minutes? So here's our equation written out. W of x is equal to 250x. In this second line, we see that 8 has been plugged in where the x was. Now we would say this is w of 8, or the words of 8 minutes. So when we see 8 here, it's telling us to plug in 8 for x on the other side as well. And of course, 8 times 250 is going to give us 2,000. So you can read 2,000 words in 8 minutes. Now, right here, this line here, w of 8 equals 200. Just to note, that is really the same information if we had the ordered pair 8, 2000. Because 8 is our x value, or our independent variable value, and 2000 is the dependent, or y value. So that same information is packed into this statement as well. We'll use that a little bit more in the next chapter as well. Okay, so what about if there was 6 minutes? So we know w of x is equal to 250x. So what we want to know is, what is w of 6? So w of 6 is equal to 250 times 6. So w of 6, 250 times 6 is going to be 1,500. Great. Sometimes you might see a problem that gives you the domain of a function, and then it asks you to find the range. So here it says the domain of f of x equals negative, f of x equals negative 1.5x plus 4 is 1, 2, 3, 4. So let's find the range. So this really should still be the same lowercase f that we see over here. It doesn't need to be a capital F. So we're going to basically sit here and we're going to plug in 1, 2, 3, 4 into this function here. So this would be f of 1, this would be f of 2, f of 3, and f of 4. So if we plug in 1, we get negative 1.5 plus 4 is 2.5. And if we plug in 2, we get negative 3 plus 4 is 1. If we plug in 3, we get negative 4.5 plus 4 is negative 0.5. And if we plug in 4, we get negative 6 plus 4 is negative 2. So we would say that the range for this function is, and we'll put these in order now, -2, negative 0.5, 1, and 2.5. Great. Let's do one more together. So it says the domain, and look, this time we've called it g of x. So whatever letter is in front is the name of the function. We can use really any letter we'd like. We typically do see F, G, and H. Those just happen to be mathematicians' favorite letters for functions. Okay, so g of x is equal to 4x minus 12, and its domain is 1, 3, 5, and 7. So let's go ahead and find the range. So let's go ahead and find g of 1. So g of 1 is equal to 4 times 1 minus 12. G of 1 is equal to 4 minus 12 is negative 8. G of 3 is equal to 4 times 3 minus 12, and there we get g of 3 is equal to 0. G of 5 is equal to 4 times 5 minus 12. So g of 5 is equal to 20 minus 12, or 8. And lastly, g of 7 is equal to 4 times 7 minus 12. That would be 28 minus 12, so g of 7 is equal to 16. So the range is the set, -8, 0, 8, and 16. And that's all there really is to function notation. It really is just another way of talking about a function. It's making just a special emphasis on the fact that this is a function. It's telling us what the independent and dependent variable is, and it's kind of giving a name for the function as well.